Today, we're going to pull back the curtain on one of the most beautiful techniques in all of algebra. We're not just learning a dry method here. We're actually going to uncover the art behind what's called completing the square. And you'll see how this one simple idea unlocks one of the most famous formulas in all of math.
Oh yeah, the quadratic formula. For a lot of us, this was just this jumble of letters and symbols we had to cram into our brains for a test. It's powerful for sure, but let's be real, it feels kind of like some mysterious artifact that was just handed down without any real explanation.
And that's the big question, right? Where did this thing even come from? Did some mathematician just dream it up one night? Did it fall out of the sky? Well, the answer is a big no. It actually has a really cool origin story, and that's exactly what we're going to dive into.
Turns out, the secret behind that massive formula isn't some super complex, high-level math. Nope, it's actually all based on one of the very first shapes any of us learned to draw, a simple, perfect square.
So here's the game plan. The entire strategy, the whole secret, is to take a messy-looking quadratic equation and just reshape it. We want to mold it into this beautiful, simple form, something squared on one side and just a number on the other. This right here is our target.
And why do we love this form so much? Because solving it is a piece of cake. I mean, if you know something squared is 9, what's the something? You just take the square root. Bam! It's plus or minus 3. It's that easy. And that simplicity is the reason we're going to do everything that comes next.
All right, so how do we take something that isn't a perfect square and magically turn it into one? Well, it's kind of like being an artist. We're going to take some incomplete pieces and construct a finished masterpiece.
So here's our block of marble, the expression x squared plus 6x. Right now, it's incomplete. But that word yet is everything. We're about to transform this thing.
Let's actually visualize this. Think of it like building blocks. The x squared part, that's our big main square. Now that 6x, let's get clever and split it into two equal pieces, two rectangles that are 3 by x. We can stick those on the sides of our main square. See what's happening? It almost looks like a bigger square, but you see it, right? That little empty corner. Our shape isn't quite complete. So what do we need to fill in that gap? Well, think about it. The rectangle side is 3 units long, so the missing piece has to be a 3 by 3 square. And what's the area of a 3 by 3 square? It's 9. And just like that, by adding that one little piece, we've done it. We've created a perfect, complete square.
What we just did visually gives us a super reliable rule in algebra. You just look at the number next to the x, in this case, 6. You take half of it, which is 3. Then you square that result, which gives you 9. That is the magic number. It's the number you need to add to complete the square, every single time.
Okay, let's put our new skill to work on a real equation. We've got x squared plus 6x minus 7 equals 0. First things first, let's move that minus 7 over to the other side to get it out of the way. Now we make our artistic move. We add our magic number 9 to complete the square on the left. We can now rewrite that side as x plus 3 squared. And from there, it's smooth sailing. Just take the square root and solve for x.
Now stop for a second, because this is probably the most important rule of the whole game. An equation is like a balanced scale. It has to stay level. If you add 9 pounds to the left side to build your perfect square, you absolutely positively have to add 9 pounds to the right side too. You have to keep it balanced. Seriously, don't ever forget that.
All right, we've totally mastered this technique on a nice, clean example. So, you ready to take the training wheels off? Let's apply this exact same artistic method to the big, scary, general quadratic equation and see what kind of masterpiece we can create.
Okay, here we go. The general form, I know, it looks a little intimidating with all the letters, but trust me, the steps are exactly the same. First, we want that x squared all by itself, so we divide everything by a. Then, just like before, we move that constant term over to the right side. See? The setup is identical.
And now for our signature move. We do the exact same thing. We take the coefficient on x, that's b over a, we take half of it, and we square it. That gives us this kind of crazy-looking term, but it's the piece we need. And of course, what we add to one side, we have to add to the other. The pattern is perfect.
All right, time to clean up. The left side, by design, folds up nicely into a perfect square. The right side needs a little bit of algebraic elbow grease to get a common denominator, but wait a second. Look closely at the top of that fraction on the right. Does b squared minus 4ac ring any bells? The final shape is starting to emerge from the stone.
Okay, we are right there. We're at the final step. The mystery that we started with, it's about to be solved. We're not just solving for x anymore, we are literally witnessing the birth of an icon.
And there it is. We take the square root of both sides, do one last little step to get x all by itself, and boom, the quadratic formula just appears. It's not magic. It wasn't just found somewhere. It is the direct, logical, and kind of beautiful result of applying the simple art of completing the square.
So, what's the big takeaway here? The formula is a great shortcut, no doubt, but understanding where it came from is so much more powerful. Completing the square isn't just a random trick to memorize. It's a way of thinking. It lets you see the hidden structure inside of equations. And that kind of insight is worth way more than just memorizing a formula.